Welcome to JAG Learning, the chemistry section. In this video, we'll be going over equilibrium using an icebox. So let's begin. Let's begin by reading the problem. 5 ATMs of A and 4 ATMs of B are put into a container to react according to the following reaction. And the reaction is right here. After equilibrium was reached, the partial pressures of B was 2 ATMs. What is the value for Kp for this reaction? Okay, to begin with, what is Kp in this overall problem? Kp is basically the partial pressure of the product, which is 5 Cp here. And since it has a coefficient of 5, actually, you raise it to the 5th power, and then you divide this by the partial pressure of the reactants. And since A has 3, this is to the 3rd, and these are also multiplied, by the way. You multiply these. And B here to the raised to the 2nd. So this is basically your Kp. And for this problem, we are given the initial state of both the products here, or the reactants. So A, right now, the partial pressure of A is 5 ATMs, while the partial pressure of B is 4 ATMs. And with this information, we actually can easily set up an icebox. And an icebox stands for, let's begin by writing it. An icebox stands for your initial, your change, and at equilibrium. So we can write an icebox for each of the elements here. And we can start out with 5 ATMs for A, 4 ATMs for B, and C right now at the moment has zero ATMs. Okay, and your change here, your variable that's going to change is basically just the coefficient that goes right next to the element. So this will change by negative 2x. This will change by negative 3x. And this will change by positive 5x, since this reaction will go in the forward direction. And this problem also states actually that after it reaches equilibrium, the reaction or the partial pressure for B is actually 2 ATMs. So easily we can find out what x is. So 4 minus 2x is equal to 2, and it's equals 1. X equals 1. You do some simple algebra there. So if x equals 1, right, what do the equilibriums for each of these equal? So simply 5 minus 3, just 2 now. And this is 5 times 1. What's 5 times 1? 5. Okay, so this is your basic premise for an icebox. And since we could go back to our initial problem, or initial equation, what our Kp is. Our Kp is, of course, the partial pressure of the product side of C raised to the 5th times, or over the partial pressure of A raised to the 3rd times partial pressure of B raised to the 2nd. And simply plugging and chugging, we go with 5 to the 5th over 2 to the 3rd times 2 to the 2nd, and even further, we go 3,125 over 8 times 2, and that actually equals 97. 1 second. Let me get it to the exact dot. 5 to the 5th power divided by 16, 195. 195. Actually, there was a problem in my calculations. I figured 2 to the 2nd power is actually not 2. It's 4. So this number here is wrong. 195. What the actual solution is so 3125 divided by not 16 but 32 is equal to 97 97. 90. 1 second. 97. What the? 97.65. And if you use significant figures, it'll be 97.7, which is equal to A, your KP.